This video demonstrates an IoT solution created by Bics and Cesanta. It presents a cellular connectivity module called Vcon. The module uses SIM card provided by Bics, and therefore it works worldwide. A Vcon module is supposed to be used inside electronics products. On this breadboard, there is a demo version of such a product. A central part of an electronic product is a microcontroller. A microcontroller is a small computer that implements product functionality, like taking sensor measurements, controlling motors, switching lights on and off, and so on. A microcontroller does that by executing a software program called firmware, which should be loaded on a microcontroller. By loading a different firmware, a device can update its behavior. As you can see on this device, a Vcon module is connected to the microcontroller, which we call a host MCU. A Vcon module provides the following functionality to the host MCU. Provision device to the AWS IoT Cloud Service, report data to the cloud, remotely control the device via AWS Device Shadow, update device firmware safely. Let me show this one by one. The first is provisioning the device to the AWS IoT Cloud Service. But before, let's answer a question: why seamless device provisioning is a problem? First, it is a problem for the end customer. A complex or cumbersome device provisioning, initial device setup, is a barrier for the product adoption, so a business can lose customers at this point. The second is complex or cumbersome provisioning can lead product vendor to roll out an ad hoc, insecure, and unreliable backend solutions, like rolling out private MQTT installations, instead of relying on proven and reliable and secure IoT services like AWS IoT. A Vcon cellular module, together with BICS management platform and BICS SIM for Things, solves this problem by providing a zero-touch AWS IoT provisioning. I click on Login to log into the Vcon management console. Here I see all devices already registered. Let me power on this new device, and it should shortly appear in this list. So we can see that it has appeared and it is online. And now we see that the provision status has changed and the device is provisioned to AWS IoT. If we scroll this table, we can see that the host MCU firmware version is absent for this device. That means that nothing is yet loaded on the host MCU. Let me load a demonstration firmware on this microcontroller that sends data to the AWS and makes a device controllable. Click on Choose Firmware File. This starts an OTA process. And when it finishes, we should see that the host MCU firmware version is updated. So here it is. It's updated to the new version. And this firmware sends data to the AWS IoT every couple of seconds. Open AWS IoT console, go to the MQTT client, and subscribe to the /app/topic. And now we should see data reported by our device. Here it goes. So we see that the name of the firmware, the version, the uptime in milliseconds, and the blink period. The next is a remote control over AWS Device Shadow. Click on Manage and choose our device and click on Shadow. This is a device shadow state. We can change a blink period in the shadow and the device will synchronize. Right now it is set to 2000 milliseconds, which means that our device blinks with 2 seconds interval. Let me update the device shadow and change the blinking interval to 200 milliseconds. I click Save, and now we can see that the device blinks much faster. That could be applied to any other characteristic of the device. and demonstrates remote control over AWS device shadow. The next is update device firmware safely. This is a very powerful feature of the Vcon module. If a device was killed by a bad update, you can always reflash it and restore back to life. Let's demonstrate it by flashing a bad firmware image, which will completely destroy the device. Choose firmware file and choose fw0.zip, which is a bad firmware. Now we see the device stopped blinking and it went completely unresponsive. If this happens in real life, a customer would face a problem reviving this device, and a business might have a big reputational expenses. But with Vcon, we just go and upload a working firmware and watch how it will be restored back to life. So now we see that it blinks again. And for example, when we want to roll out a product update, say changing blinking LED from green to red, we just go and push a new firmware. And when it finishes, the blinking will change. Okay, so now we see it blinks red.